In addition to using satellite imaging to map the Earth's surface environment, we often want to use it to detect changes to that environment. And we can distinguish two different ways of doing that. This is the field that we call change detection. One way of doing it is to use two separate images. And so we look at changes between an image that we assume has been taken before some kind of change happened, and then another image that was taken after. Another approach is to use a whole bunch of images. This could be tens or hundreds, even thousands of images in what's called a time series. And we analyze all of these images in sequence to try to find out when changes happened, and ideally what kind of changes happened too. Right now I'm going to talk about one of the ways in which we can detect changes just using two images. The thing I'm going to talk about now is what's called post-classification change detection. And how it works is sort of explained in the name of it, post-classification. So we have two images. One image is taken before the change that we're interested in, and this change can be an earthquake or a flood or a fire or more subtle things like development of a new subdivision in a suburban area. So we have one image that's taken before this change and another image that's taken after. And we then classify the first image. So as a quick example, we have an image here. Obviously, my example here is grossly small in comparison to a real image. We have 3x3 image here. Normally, satellite images have thousands of rows and thousands of columns. But we can imagine we have a classification, our first image here, our before image. And we have maybe mapped forest, forest, forest. Maybe we have a bit of water here. And we have an urban area down here. Then something happened, or at least we assume that something happened. And so we want to find out what happened between the before image was taken and the after image was taken. It's important, of course, that these two images cover the same area and have characteristics that allow them to be classified in the same way. So here we have our after image. We run a classification on that, and maybe what we find, probably the river hasn't changed, probably the urban area down here hasn't changed either, but maybe somebody built some more urban areas up here into the forest. Post-classification change detection is conceptually really simple, and it's often a great way to do change detection because it gives you two things. It figures out where things have changed. In our case, that would be these 2 pixels here. But it also tells you directly what that change was. We can see that this area used to be forest, and now it's urban. So we get both. We get a detection of the change, and we get an attribution of the change. The one disadvantage of using post-classification change detection is that it's rather sensitive to inaccurate classifications. You can imagine that if we have a couple of pixels over here that are incorrectly classified, and a couple of pixels over here that are incorrectly classified, once we combine them, and we look at changes from before to after, those errors in the two images are going to compound. For example, let's imagine that instead of having a forest class over here, we actually misclassified it as an urban area. What we'll see then here is that we have an urban pixel here and an urban pixel over here, so we'll think nothing changed, but actually it did change. We can have other issues, of course. Let's imagine that we had mapped the forest down here instead of the water. Now we'll think that we had a change from forest to water. Maybe we think that this area has flooded, but it could be just a misclassification in this first image. And that's just with 2 pixels over here. If we had 2 pixels misclassified in the after image, those would add to the misclassifications from the before image. So post-classification change detection, it works really well, and it's very simple if you have very accurate classifications, both from your before image and in your after image. But it is rather sensitive to misclassification. So if you work in an environment with classifications that you think are not so accurate, you should be very careful with using this approach.